All right, hi again. Great you're up for a second video. Let's talk about the course logistics. In general, Atoms is a master level module. You can obtain 6 ECTS for your transcript. Depending on your program, it's either a mandatory elective or an elective module. And speaking about prerequisites, as I already said, it is good if you have completed business analytics and data science beforehand. It's not mandatory, it's good if you did, because I will assume that the concept we examined in BADS are known to you. And I will not have time to revisit them. Yes, well, and with regard to the ordinary organization, in theory, we would have had a lecture Wednesday morning, and we would have had a tutorial session, well, 2 actually, on Thursday morning or Wednesday afternoon, where the idea of the lecture would have been to discuss relevant concepts with you, learn about deep learning technique, for example. And the purpose of the tutorial would have been to train you in Python programming, looking into important libraries for Python libraries for machine learning and deep learning. That would have been the idea, but well, as you know, it's not going to be like that. Rather, we will deploy a everything's digital strategy, and for summer 2020, what we will do, as you may have noticed already, right? We'll pre-record all the lecture sessions and then make the videos available to you in the format that you are just experiencing, and I hope you're okay with that. I will do something alike for the tutorial sessions. In the tutorials, we work with, well, pieces of code for the experts, Jupyter notebooks. And the idea would be to do some code walkthroughs using these notebooks. So looking at problems, looking how we can solve these problems using Python, looking at standard jobs, cleaning some text data set, for example, how that works, etc., etc. I will do that and pre-record it as a video and make that video available. That's going to be the format. And I guess that this will work pretty well. Obviously, lectures and real-life tutorials are advantages in that we can, just come together, we can talk, we can have discussions. And discussions are so important, so valuable. Via the video channel, we can't have these discussions. And I'll do my best to, provide you with good content that helps you in your studies. But I do believe that we will need some live sessions on top of that, just for Q&A. So my plan is to host some video conferences using Zoom, where you can then just join in, make comments and ask questions. I will not prepare any materials for these live sessions. I will just, free some time to talk to you so that you have a chance to ask some questions. Obviously, I expect you to watch the relevant videos beforehand, as there will be nowhere near enough time to revisit everything covered in the videos in these live sessions. And please note, I do need to have, video conferences for all my seminars and other lectures as well, because every lecture is going to be digital only this summer semester. So there won't be that many live sessions for Atoms. And hence we will also use the Moodle forum in order to sort out problems. And there I really count on you also supporting peers. If somebody has a question, please write a post to the Moodle forum And if somebody has an answer to that question, or at least some comments he or she wishes to share, please do so. Please also take responsibility, become active, and reply to the questions of your peers. That's going to ensure that every issue, question you might have on your chest will get resolved, and that every one of us can enjoy the course and benefit from it. Okay, so really please take that by heart. Normally the crowd in this course is rather heterogeneous, from people who did bad and now want to learn more, all the way to experts who know a lot more than I do and could easily give the course if they were wanting to, and are very, very capable to help others, support peer students, and help with sorting out questions that might come up, right? So especially to the experts among you, please also take responsibility and help me with helping out everybody else, okay? That's great. Course materials, obviously Moodle will be important this semester, and the Moodle page looks pretty okay, I believe. Much material is already online, slides for all the lecturing sessions, and I'm now starting to pre-record the videos. There is no course key in this semester, so every material is freely available to everybody. Just sign up for the Moodle course if you wish, in order to get notifications if somebody posts something in the forum. And either way, you'll find the lecturing slides and in due course also material for the tutorials in Moodle. That said, for the tutorial materials consist of data that I might make available on Moodle if I'm not allowed to share that to the public. But the main material for the exercises are Jupyter notebooks, and I will make these available via GitHub. We can maybe have a quick look at both our Moodle page and also GitHub. That's our GitHub page. Humboldt-WI, Wirtschaftsinformatik, Business Informatics, /Adams. Oh, well, bear with me. Let me quickly check whether you can actually see that in the video. Can you? Oh yeah, you can. That's good. Great. Everything works like charm. So that's our GitHub repo. And you do see the first 5 exercises here, each in its own folder. The list will expand. Note that I haven't updated the exercises recently, 12 days ago. If you wish to take a look into the exercises, please do so. You find the Jupyter notebooks in these folders, and at least as of today, the relevant data for the tutorials is also available in our course folder. Adams, here you have data. App Store data, university admission data. The thing is, we will use some data sets that are freely available, for example on Kaggle, but the owners of their data don't like their data being shared on other sites as well. So Kaggle, for example, obviously has an interest that if you want to pull their data, you go to the Kaggle platform and get it from there, as opposed to me sharing it in our GitHub repo, right? So I haven't really decided yet whether data will be available here as well, or whether I will ask you to just pull the relevant data sets from their original sources. As of today, the data for the tutorials is still in that folder. And also in the slides, occasionally you might see some Python examples to further illustrate concepts. These codes are also available here in the folder lecture codes. Right? Everything that is available today is preliminary. Maybe we can agree on this mode that once a video lecture for a tutorial is online, then the corresponding material is final. Before that, I just might to do some updates of the tutorial, so don't be angry with me if you now go to exercises, work yourself through the first 5 tutorials, and then later realize by watching the videos, for example, or just scanning the videos, that the tutorials have changed. You have been warned. Everything is pre-major right here, but you can definitely familiarize yourself with GitHub in case you haven't used that platform before. That would be great. And again, request to the experts of you, the very idea of GitHub, let me go back to our slides, the very idea of GitHub really is to enable collaborative work. So the system provides many functions to work collaboratively. If you have ideas to improve the tutorials, or if you implement some changes, you add some comments to code, you write some more explanation, you find a better way how to perform a task, please share that with me. Okay? I reuse tutorials that have been developed by previous colleagues who have meanwhile left my group because they finished their PhD, so that's actually the first time I run the tutorials myself, and I very much appreciate your support by the expert programmers of you, helping with further improving the materials so that you can take the most value from that. Okay, now what are our topics? We have 3 blocks, 2 big blocks and a smaller block. Our first block is Foundations of Artificial Neural Networks. We'll introduce neural networks, this famous algorithm that I have left out of BATS, revisit the foundations of these techniques, how neural network models are trained and tweaked and tuned. And in the tutorial part, in BATS we did use R. And now we use Python. You might wonder, why on earth do I have to learn yet another programming language? Fair question. On the one hand, because I want you to learn another programming language, Python is the go-to method when it comes to deep learning, I believe. If you want to do deep learning in industry, most likely you're going to use Python. So learning Python is something that makes very much sense. Also, certain functionalities are so much easier in Python compared to R. So it really makes sense for a deep learning course to use Python. And again, thinking about industrial careers, the 2 prevalent platforms for machine learning today probably are R and Python. And if you know both, that is clearly in your interest or gives you some advantage. It's valuable. That's what I'm saying here, right? So it makes good sense to learn it. We will have 1 tutorial to introduce you to Python. We will then, in the second tutorial, revisit some standard machine learning workflow in Python using scikit-learn, which is the go-to package for machine learning in Python. And then we will move on to neural networks, trying to implement these from scratch. And then afterwards, look into libraries, how to use neural networks in real-world applications. We've opted for the Keras library, which is now part of Google TensorFlow. Keras is a high-level library, which means that we can do a lot. We can't do everything, but the things we can do are sufficient for our course and are very easy to do. That's the big advantage of Keras. If you want to dive deeper, learn about TensorFlow or PyTorch or the many other platforms, I invite you to do so. Please do not expect this course to cover this. We just cannot. Block number 2 is all about NLP, natural language processing. We will look into deep learning modules for natural language starting from recurrent neural networks, which are a type of module or a family of model for sequential data. Sequential data is something like a time series, but it's also something like text, because text, spoken text, is a sequence of words that come naturally one after the other. And there are specific type of neural networks for such sequential data, RNNs. We look at these and how they are applied to text data. And then we revisit some of the modern concepts to do NLP using deep learning. We learn about text embeddings like Google's Word2Vec, transfer learning, and we will learn about transformer networks, which represent the state of the art as of today. And generally the idea of the tutorial is to follow the lecture and demonstrate at least some of the concepts that we cover in the lecture. We will, for example, use recurrent neural network to predict financial time series. That's something we as economists are interested in, I believe. We will develop our own embeddings. If you haven't heard the term embedding before, don't worry, right? We will look at Google's Word2Vec. We'll do sentiment analysis using tweets. I'm seeing the slide promise you that we will look at tweets about stock prices. We might explore sentiment analysis in a different domain. Well, to be seen. So, basics of neural networks, block 1. Neural networks for language processing, block 2. And then our last tiny block will be on images. Very much as the recurrent neural network at least used to be the approach for text data, convolutional networks, or CNN for short, are the standard technique to process image data. And although we will not spend a great amount of time on image processing, because, well, arguably applications of image processing in economics are yet scarce. So I think it makes more sense to emphasize the text part, but at least I want to give you an idea what image detection, image processing is about, and how CNNs, convolutional neural networks, facilitate image analysis. And then certainly in the tutorials we will also look at CNNs. That is the scope of the lecture, and I hope you like it. I have to say I look quite forward to it, and hope that many of you will not only start but stay with me till the very end. Where then some sort of assignment is waiting. Well, good news in summer 2020 is that I can promise you that the evaluation of atoms will not be affected by Corona and all the changes and challenges the virus is bringing about. The assignment is an individual assignment. You will work on a modeling problem and approach that problem using the concepts you have learned in the course. That's the idea overall. You will develop a notebook, a Jupyter notebook, which comprises explanation, maybe a bit of literature as well, a careful analysis of data, and subsequently your solution to your modeling task. So a mixture of explanation, Python code, and empirical analysis. That is what makes up these notebooks. And well, when the time comes, I will elaborate in a bit more detail how I evaluate these notebooks. It's essentially a written piece of work, a bit like a homework or a bit like a seminar dissertation, and I will grade them in a similar way. I think that's enough for now. Is your notebook well organized? Is your argumentation sound and convincing? How about your code? Is it clean? Is it readable? Is it adequate? Do you blend explanations and codes and visuals, graphs, tables, in a sensible manner? Do you use these elements wisely to develop a compelling data narrative in your notebook? These are the things I will look at. And it's going to be an individual assignment, so everybody will work on this on her own or on his own, then submit solutions and receive grades. And the deadline for submissions is going to be the 28th of August 2020. I will have 3 alternative topics and offer corresponding data. And the alternative topics will touch on the blocks of the course, financial time series forecasting, which is the first block and also a bit of the second block, these recurrent neural networks that come into play here. There will be a task concerning image analysis and a task concerning text analysis. I might have more than one option for, let's say, text analysis, given that we spend so much time on text analysis in NLP, but this is yet to be seen. I haven't really decided what the tasks will be. There will be 8 alternative tasks. I haven't yet decided how I will handle the allocation of tasks to students, maybe some sort of preference voting I could imagine. And I also welcome propositions for, well, your own topics. If you have a cool idea for a task to work on, we can discuss. I guess no promise, but I think this makes sense. More information on that when the time comes. And obviously discussing the assignment is one of the things we need to do together. So that's definitely one meeting we need, one live meeting via Zoom to elaborate a bit more on the individual assignment. But since the deadline is long after the semester ends, or at least the lecturing period ends, I think this can wait a little longer. How about resources, textbooks? Probably especially useful this semester where there are no on-site lectures. There are many great resources out there on deep learning and the stuff we look at. If you ask me for my one-time favorite, that is the one. Dive into deep learning, which is it's definitely not a book. It's so much more than a book. It's a paradise to learn about deep learning. Maybe best described in the words of the authors, an interactive deep learning book with code, math, and discussions based on the NumPy interface. Well, in case you haven't heard NumPy before, that's a very popular library for linear algebra in Python. Check out the website. It's excellent by every means. You have a really comprehensive coverage of deep learning at large, great explanations that combine rigor, formalism with intuitive and approachable explanations. You have a vast number of notebooks and code available that you can use. It's really a great resource and I use it a lot in Adams. Nonetheless, Adams is a blend of different resources, so it's not all based on that book. But honestly, if you don't like the video channel or what I'm doing, but still want to take the course, if you work yourself through, dive into deep learning, go through the exercises, go through the explanations, do the tasks, then, well, I bet you will finish in the top 1% of all course participants because this resource is so good. But it's also a lot more than we will cover. So if you really want to work yourself through all the chapters, that would be quite remarkable. But check it out, it's great. Some more credits. In addition to the dive into deep learning by colleagues from UC Berkeley, There is also a publicly available lecture from MIT, Introduction to Deep Learning. That has a lot of overlap with Adam's in the first parts when it comes to introducing neural networks, for example, or neural networks for sequential data. Subsequent sessions of the MIT course are a bit more technical and go away from what we do here. Then there is a fantastic lecture from Stanford, Natural Language Processing with Deep Learning. They update this lecture every semester to include the very cutting edge stuff. They have also videos available, slides available. Not sure they have demo exams. Check it out. It's also one of the sources that I have used a lot when developing that course. And last but not least, you find a great YouTube lecture by Nando de Freitas from Oxford on deep learning. It's a little bit dated by now, at least the YouTube lecture. He was holding this lecture in 2015. But Oxford also has a very nice GitHub repo for their deep natural language processing course. I would say that, especially for the NLP part, the materials from Oxford that I point you to here are very useful. At the same time, this is the focus of the Stanford lecture, Deep Learning for NLP. So it's probably a good idea if you take a look at all these sources and check out which one you like the best. Obviously, however, my ambition is that you don't really need any of these resources, because I aim to provide the materials that have all you need, right? Still. Final note on tooling. We will use Python, I said that. Unfortunately, setting up an infrastructure for deep learning and Python on your own computer is surprisingly complicated. I might exaggerate here a little bit. But say you've used R before in BEDS or other courses. You download it, you install it, then you install RStudio, done. It's pretty neat, I think. For Python, well, it's similar. It works in a similar manner, but somehow it is often found a bit more complicated. And to be really honest, me setting up the environment for Adams, that also took a good 2 days or so of things not working properly or the way I wanted to, and yeah, it's a bit painful. So first of all, you need to make one key decision. Do you want to set up your own computer to run exercises and use that for the course? Or do you want to use a cloud platform where you could, for free, interact with a programming environment over the web browser without any need to install anything? And while there are alternative platforms available, most likely you would use Google Colab. If you have a Google account, nonetheless, Google Colab is a very nice platform. I encourage you to check it out. In a nutshell, you have your development environment, so something like RStudio. If you've used only R before, think of it as something like RStudio, the environment in which you write your code and you run your code. But you have that in the web browser, and whenever you execute some code, that code is actually run on the Google Cloud platform, and on that platform all the necessary packages, pretty much all of them, are just available. So the computer is set up, you just have to use it. Very often it will be just like that. What's the downside? Well, you need a Google account, you probably also need a Google Drive account, etc., etc. Some people are maybe hesitant. I don't know. If you're hesitant to sign up with Google, which is okay, but then this option is not available for you. Other downsides, the platform is not as extensible as your own machine, where you could do everything. For the course, for Adams, it's definitely enough. You can do everything you need in Google Colab, including the individual assignment. If you want to take future courses, maybe also do your dissertation in that field, at some point you will need to familiarize yourself with the infrastructure. You will need to learn about things like Anaconda or pip, which are tools to install Python libraries. You will also need to learn about the infrastructure, which can be a little bit painful, as I said in the beginning. If you go through that endeavor, you will be able to write your code either in a notebook environment like Google Colab, or using some proper, let's say, integrated development environment. I'm highlighting some tools here. There is Spider. I don't use it, but it's somewhat popular. There is Visual Studio Code by Microsoft. I don't use that as well, but many of my staff use Visual Studio Code and like it quite a bit. And then there is PyCharm, which is the tool I know a little bit about because I do use it. And you know, writing your code in one of these development environments is a bit more convenient. You have some functionality that you would just not have when you use Google Colab or when you write code in a Jupyter notebook. It's a trade-off. If you don't know these tools, learning them will cost you some time, full stop. If you invest that time, you get some advantages. Well, when the time comes, I'll show you some demos, but I'm already running out of time, so won't do that right now. Think about whether you want to set up your machine. The blog post by Jason Brownie or from machinelearningmastery.com, by the way, very useful website, is a good starting point. You will also find some slides on Moodle, which my former assistants compiled, best practices to set up your computer. Have a look at these materials. Disclaimer, I will not be able to offer you much support when it comes to setting up your computer. Many of you use Mac, and I don't know much about Mac because I'm a Windows guy, you know, and generally I'm not the tech expert here. As I said, it did cost me 2 days to set up my environment, roughly. Okay, so when I get a question and I know the answer, obviously I will share it. But in general, it's obviously your responsibility to set up your machine if you decide to do so, and you don't have to if you don't wish to. All right, that's it. That's all about the course Logistic, and we are ready to move on to a next chapter, and we'll do so in a subsequent video. Thanks for watching, and bye-bye.